Hi, good evening, good morning, good afternoon, everybody. So today we will discuss about the OSPF headers, packet types, and the OSPF message adjacency. And along with that, we'll see how this DR/BDR election happens. And I will walk you through from LSA type 1 and type 7. And also we will discuss about the case studies of OSPF, and we have a list of questions, most OSPF questions. So I'll try to answer that. Yeah. So let's quickly start the OSPF topology. So in the last class we discussed about what is different area type, what is single area, what is multi-area, and what is the role of ABR, what is the role of ABR, and what are the different types of LSAs, and how do we see those LSAs. So now let me walk you through what are the different types of LSAs, right? From LSA type 1 to type 7, we discussed until type 3. So we are going to continue the LSA type 4 until like type 7. And we'll take a packet capture and we will see what are the different types of OSPF messages that's being exchanged between the neighbors. And we'll see, we'll do a troubleshooting, what happens if I change the different area type, and what are all the different error messages, and how you can leverage your troubleshooting with the OSPF commands. I'll give you some useful commands to figure out when you encounter such problem with OSPF, how you're going to find out very quickly. And I am very confident that if you guys have a very good understanding about this particular topic, what we are going to discuss today, you will definitely crack any kind of interview, because we are going to discuss, as I said, we are going to talk about all the OSPF messages. We are going to discuss about all the OSPF LSA types. We are going to talk about multi-area OSPF types. So to start with, let me start with OSPF messages. The very first thing we should know about OSPF is the hello packets. Hello packets are very, very important in the OSPF. Why? Because in every 10 seconds, it sends an hello, and the hello is sent to the multicast address. So I'll give you with a diagram. I'll give a better visual of how exactly this happens. So let me take my pen. Okay. So we'll start with very small topology. So we got two routers, R1 and R2. So it sends, when you kickstart, or maybe I would say when you didn't enable an interface on this particular port on router 1. So it is considered as a down state. And we got init state, extract, and exchange. And then it loads and it becomes full. Don't worry about that. We'll go one by one. So when you didn't enable anything on this OSPF, OSPF, we all know that OSPF is per interface level config. So you will just throw your networks with the command, neighbor command, right? Example, I have 10 network hanging over here and the 20 network over here. It's very simple design, /24. So when I throw this network out, right? When I advertise this network over OSPF, So my neighbor is here 20.0.0.1. The guy over here is 20.0.0.1. And this guy is 10.0.0.1, just for an example. So I didn't enable the OSPF. OSPF is, as I said, it is an interface level config. So I have to do IP OSPF network type point to point. So we discussed about this in the previous class. So for this particular network type, there is no DR and BDR. The DR and BDR happens only in the multi-access network. So when people they ask, when in the OSPF point-to-point connection, do you see DR BDR, and can you see type 2 LSA? This is the most asked questions. You never see type 2 LSA in the point-to-point because there is no DR BDR election in the point-to-point connection at all. Yeah, right now coming back to the states. So when you enable your OSPF, then it starts with init state. So here actually your master and slave election happens. This is all more dynamic and it is all handled by the OSPF protocol. So we have no control about that. This is about who manages the LSAs a lot. I mean, again, every device sends a link state acknowledgement to the multicast address 224.0.0.5, and this stays within the area. Let me take another color to differentiate this. So imagine this is area 0 and this is area 1. So my LSA is never flooded over the area 1 here. So my LSA stays within this. So over here, the green color, I circle with green color, this LSA never been flooded to router 1. So init state is something when you enable OSPF, it kickstarts your init state. And xstart is something I'm sending the LSAs. I'm going to start my LSA updates. So for that, I have to first establish a neighborship with my remote router. And exchange is actually it's a bidirectional. So when I do an xstart, I'm sending all my LSAs out there to router 2. And the same way, this guy is going to send all his LSAs back. We'll discuss about this, but this LSA doesn't contain all the LSAs, right? Because in the earlier class, we discussed about that in the multi-area OSPF, there should be a guy in the middle. He's called as an ABR. So if you want to reach any directly connected network over here, so the ABR is actually helping us to reach to this area 0 here in the left hand side. So I cannot, this particular traffic cannot traverse directly to the other area without the ABR, right? So this LSA which I am talking about when I am making a neighborship and I am talking about within the same area. So if it is in a different area, if I send an LSA, actually this ABR is a guy who is going to translate my LSA type 7, sorry, LSA type 5. Let me write this again. So he will transfer all this LSA type 5 to LSA type 7. We'll see that in detail in the lab. So here, In the exchange state, both devices are sharing their LSAs. So once this happens, it goes to the loading state, and finally you know it establishes a connection with the neighbor and it becomes a full state. So no worries. I will show you the detail. Now let's jump to the presentation. So in the very beginning, it will be in the down state. As I said here, I didn't enable any OSPF. No OSPF. It is an interface level config. So in the init state, it's sending an hello with this router ID. If you see this router ID of this guy is 1.1.1.1. It's an init state. And for this, I receive a two-way state, init state, and then after that two-way state, there you see it has seen this router ID of router 1, right? 1.1.1, and it is advertising its router ID 2.2.2. So he has enabled the OSPF right now here at this state. This state OSPF is enabled. And here in this particular diagram, this is happening between the multi-access network. The logic is same for your point to point. But here in this diagram, because in the multi-access network, we have a DR and BDR election, whereas in the point to point, we do not have a DR and BDR election. So that's why, we are discussing about this. So in addition, in the multi-access network, when you are doing the OSPF point to point, all this information remains the same apart from this DER BDR election. But when it comes to the multi-access network, along with my other messages, the DR and BDR election happens. So that's the reason we have this packet over here. So the DR and BDR election happens right over here after this two state. First init state, as we said, it advertises the router ID of router 1. And in the two-way state, why it is named as a two-way state, because it has seen the router ID of router 1, and along with that, it is throwing its router ID, router 2, 2.2.2. So this guy is telling, okay, I seen your router ID now. Now the DR and BDR election happens. So by default, the priority is 1 for both the devices. So if you change the priority, you can make control over your DR and BDR. But it is always if you have some topology, something like this, because here I want to give a quick rundown about the enterprise infrastructure. Okay. So example, if you have 3 routers connected to a switch like this is your core switch, and this is your internet router, and this is your MPLS router, just for an example, and this is your maybe a voice router used for your voice services. So this guy over here, right, is in area 1. All are in area 1 because this is multi-access network. Let me take a different color for this. So this is a multi-access network. So in this case, right, all are in area 0. And I got one more connection going here. right from this voice device, and that is area 0. And I got one more link like this, it is going to area 0, just for an example. So the DR-BDR election happens only between this green routers here, because it happens only in the multi-access network, not in the point-to-point. So this guy over here, the black lines, it is a point-to-point, P2P. So in this case, if my switch, right? So if you think, okay, my switch has to manage all this LSAs more perfectly than other devices, you can make this device as a DR by changing the priority value over here. Then in the DR and BDR election, so one device will be a DR. So in this example, let's consider a switch become an a DR, because it got the highest router ID. If you haven't configured the priority, the highest router ID will be, elected as a designated router. So this guy is elected as a designated router here. The switch, the black one here, switch is a DR now for this topology. And imagine this guy over here is a voice router is a BDR. And all the other devices, the grain routers will become DR other. So example, there is not a tie, I would say. This guy over here in the left, the internet router has a highest router ID, then this guy will become a DR. If this both switch and this voice router, if both go online, then apparently in the DR other, it will check for the highest router ID, and the internet router will become a DR for this topology. So this is how the DR election happens. So in the beginning example, say for example, you got two routers, and this topology, this device got a highest router ID. So this is selected as a DR. So here comes the extart states, where the database descriptor packet, it contains the LSA. As I said, here it starts your LSA, link state advertisement. So what is link state advertisement? Right now in this particular topology, I got only one link over here. Router ID is 1.1.1 that is physically assigned to this interface. So for this device, 2.2.2. So my link state advertisement from R2 is this guy. This is my LSA, and this is an LSA for router 1. And if you have multiple interfaces connected, all are your LSAs. Example, if I got 3 interfaces, I got 3 LSAs. Right over here, if I got 3 links, then I got 3 LSAs. So it depends on how many interfaces you configured with an IP address, that becomes your advertisement, link state advertisement. So the database descriptor packet is something, it got the LSAs. And this LSA, let me erase this. Okay, we got it until this point. And inside the DBD example, it maintains a link state database, LSDB. So both devices maintains this LSDB. We'll see that in the lab. It is inside the OSPF database. So here it will give all your LSAs. Inside your LSDB, you got your LSAs. So example here, I got 1.1.1.1. And right over here, I got 2.2.2. And if I got one more loop back, something like 3.3.3, and my second LSA is 3.3.3. So now, right now, we got only two LSAs and one LSA on router 1 and the other LSAs on router 2. Both are in same area because this is multi-access network. Yeah. And if you see this X start state, it is sharing its LSAs. So once it happens, the X start state, it's both exchanging its LSAs. So in the exchange state, it contains all the LSAs to reach the network from router 1 to router 2 and router 2 from router 2 from router 1 all the way back. It's a bidirectional communication here. So once it goes to the loading state, it is called as a link state request. You know what, when it happens, example, in the beginning you established a neighborship with your OSPF and suddenly you add a new network, something like 4.4.4. So I'm configuring a loopback 4. So here, this guy over here will send the, if you see this, this is again a bidirectional from R2 to R1 and from R1 to R2. So this guy is going to send a link state request. Hey, what is a new network you configured? Can you give it to me? I want to reach. Because without this, I cannot build my LSDB. So once it does the link state request, it will send the link state update. So now it is telling that, okay, you can update your database with this network 3.3.3. So now this guy is going to send this loop back to this guy for this link request coming from R2 back to R1. So it's going to update is LSDB 4.4.4. So now both got the same LSDB, but this is never flooded across a different area. Now we both are in area 0. So once it received those LSDPs, it's going to send a link state acknowledgement from both sides. And you know what? This link state acknowledgement goes to the multicast address 224.0.0.5. This goes for all the routers within the same area using the multicast address. So when somebody is asking you, the multicast address within the area it uses is 224.0.0.5. And 224.0.0.6 is a multicast address only used between the DR and BDR for DR and BDR election. This is very important. So once it exchanges the complete information, both devices got the complete database. Both has the same link state database. So now all my networks has been flooded properly to all the devices within my area. The same logic applies for multiple devices in the same network. Even if I have 10 devices in the multi-access network, and if I have a complete neighborship with them, the same packets is being exchanged between the devices. So then it becomes a full state. We'll do that in the lab and we'll see how this goes from down state to full state. And I'll show you the commands how to check. And also in the Wireshark, we'll see all these packets. So that's about the complete rundown of OSPF messages. And there will be some troubleshooting example if you get stuck in your two-way state. And what if you get stuck in your, most of the time it will be in a two-way state, because this guy will advertise the hello, but if you haven't enabled the OSPF on this router, it will get stuck in the two-way state. It will not move forward for X start or exchange state. because both has to see the hello. Only then it progresses to start state, then comes exchange, loading, and full state. So that's why whenever you give show IP OSPF neighbor, you would see full state there. Okay, fine. So now going to the slide. So hello packets are OSPF packet 1. These packets are multicast periodically to 224.0.0.5. Multicast address and all the interfaces, enabling dynamic discovery of neighbors and maintains neighborship. On broadcast and non-broadcast multi-access network, hello packets are used to elect DR and BDR. On the non-broadcast multi-access network, hello packets are unicast to neighbors address configured on the router. Manual neighbor configuration is required for NBMA network. We'll see that. And followed by that database descriptor packet. For link state routing protocol, it is required that link state database for all the routers remains synchronized. That is important. If you have 5 routers in the same area, all should be synchronized with the same link state database. So synchronization starts as soon as the adjacency is formed between the neighbors. OSPF uses database descriptor packets for this purpose. And coming to link state request packet, the link state request packet is an OSPF packet 3. After the database descriptor packets exchange process, the router may find it does not have an update to the database. The LSR packet is used to request pieces of neighbor database that is more up to date. As I said, if you add one more new network over here, it's example something like 4.4.4, and it can be any network. When you add, if imagine router 2 and router 4 are both are in the same area, it is an NBMA, and this guy is a DR and this is a BDR. So what happens here? It sends a link state. The router 3 sends a link state request, because this particular network is it's something you configured now recently, and I want to know about that to update in my link state database. So the link state update packet, or OSPF packet 4, these packets implement the flooding of LSAs. Each LSA contains routing, metric, and topology information to describe a portion of OSPF network. The router advertises LSA with an LSU packet to its neighbor routers. In addition, the local router advertises the link state update packets with information in response to the LSR packet. So the link state update is, okay, you are expecting me to send my network something I added recently here. It could be 5.5.5.5. For your LSR, I will send an LSU link state update. Here you go. You take this and update in your LSDB, because we are all in the same area, area 0. We are running in a single area now, because we are all NBMA networks. So the link state acknowledgement. Link state acknowledgement packets are OSPF packet 5. OSPF requires acknowledgement for the receipt of each LSAs. Multi LSAs can be acknowledged in single LSA packets. Example, if you configured one more network 6.6.6, and this link state acknowledgement, right? For this link state update, this guy over here for this LSU, I'll use a different color to differentiate better here. For my link state update, this guy is going to send the link state acknowledgement. So you don't confuse with link state advertisement and link state acknowledgement. So this is link state acknowledgement. So it is giving an acknowledgement for both 5.5.5 and 6.6.6. It can do that. So acknowledgement for the receipt of each LSA, multiple LSAs can be acknowledged in a single link state ACK packet, LSAck. So example, if you see, if I take a different color to differentiate this even more better, let me take this. So example, this guy got two LSAs. One is 5.5.5, 6.6.6. I got two LSAs. For this two LSAs, it can send a link state acknowledgement. Okay, I received the network 5.5.5 and 6.6.6. That's the whole meaning of that. And coming back to the database descriptor packet, in the OSPF, the database description packet are used during the initial phase of neighborship adjacency establishment to exchange information about the link state database. As I said, if you have two routers in the same area, the LSDBs remains the same. That's the whole logic of link state. OSPF is called as a link state protocol because all the routers within the same area has the same LSAs. We discussed about the type 1 LSA, type 2 LSA, and type 3 LSAs. So imagine you got only type 1 and type 2 LSA because this is NBMA again. So your type 1 and your type 2 LSAs both and on both devices it is same. So sequence number, each database descriptor packet includes a sequence number that helps in synchronizing the OSPF database between OSPF routers. The exchange process, the database descriptor packets are exchanged between OSPF router to determine the synchronization state of their link state database. If there is any discrepancies are found, subsequent exchange state request and link state update packets are used to update the databases. The efficiency, the use of database descriptor packet helps OSPF router quickly determine whether their database are in sync without having to exchange the entire content of their database. If there is one specific change you do it, only that particular update will be sent and not all the link states. I think this is more than sufficient for us to understand the OSPF packets. Let me quickly, go through this and I'll help you guys to walk you through this. In OSPF, the link state update packets are used to communicate changes or updates to the link state information within the area. That is very, very important. So, and link state update packet contains specific link state advertisements. As I said, if you got two networks, 1.1.1, 2.2.2, these are all called as LSAs. So LSA update packets are generated in response to changes in the network topology, such as a link going up or down, a new router or network being added, or when an LSA information needs to be refreshed due to its aging time expiring. So when a router generates an LS update packet, it sends it to all the other routers within the same OSPF area. That is again very important. This happens only within the same area. About the updated or newly originated LSAs. Propagation. Upon receiving an LS update packet, router examines the LSA contained within it to determine if they need to update their own link state database. Each router then floods the LSAs to all the routers within the area, ensuring that all routers eventually have consistent LSDB. So this is never ever flooded to other areas. That is very important. Database synchronization. The LS update process helps maintain consistency across all routers LSDBs within an area, same area, OSPF area, ensuring that every router has an accurate view of the entire network topology. So upon receiving all this packet, it is building its LSDB. That's why when we give show IP OSPF topology, you will see the complete LSA details inside that. And this is same for all the routers in the same area. Okay, now jump into the lab. You will see exactly how do we see this, and we'll take a capture. Just 1 minute, guys. Let me log in my device. It's a bit slow. Let's wait for us for some time. I'm trying to connect to my device. Yep. Okay. So this is our topology today. So I'll give you a quick insight about the network configuration here. So if you look at this, this is an area border router, and this guy is an ASBR autonomous system border router. We'll discuss that, what it does. And this guy here, we are running EIGRP. We are redistributing the routes into OSPF. Let's see that followed by the current topic what we are discussing now. So here between these devices, I'm using the 10 network over here on Ethernet 0/0 and Ethernet 0/0 over here. And for now, we'll see only about these two routers. I mean, when we are discussing about the topic of redistribution, the let's say type 7, I'll explain what is the network configured here. But for now, for the link state update and link state request and OSPF packets, so now we are just focusing on these three devices right over here. Let me delete this. So here I configure .1, 10.0.0.1 on this guy, ASBR R2. And here in R3, this is R3 is an area border router because the Ethernet 0/0 is on area 0 and Ethernet 0/1 is on area 1 here. You guys can see this, I think. I mean, this is a area 1 and this is area 0, and this interface is on area 1, and this guy, this Ethernet 0/0 is on area 0. And between this R3 and R4, I establish a connection using the 20 network 20.0.0.1, and the subnet mask is /24. And same thing right over here, Ethernet 0/2, it is 20.0.0.3. So now, right now, we just involved these three devices in the OSPF right now for all our testing. So now going back to the config. So if you look at this is R1 right over here, this guy. It's on 20 network. Let me show this, show IP, interface brief, exclude unassigned. And followed by that, we will erase the OSPF config, we'll redo from the beginning. But for now, we will go through the packets. For that, I have enabled the OSPF. We will redo the OSPF after finishing the discussion about LSAs and other OSPF packets. So if you look at this is R2 here. So I want to jump into R1 right over here. This is R1, this guy. It's on area 1. If you give show run section OSPF. So let's forget about this areas. This is something I want to show you, LSA type. So I have configured this. So right now, this guy, it is configured as a broadcast network. If I go to the Ethernet show run interface, Ethernet 0/2, this is OSPF network broadcast. So let me take my pen. Right over here, this is a broadcast. So a link between this Ethernet 0/2, both are in broadcast, OSPF broadcast network, that is called as NBMA. Broadcast, both interfaces are in broadcast. So network type is a broadcast. I am on R1 in Ethernet 0/2. The OSPF network type is a broadcast. And the IP address is 20.0.0.3 and it is 255.0.0. And if I open show IP OSPF database, so we are discussing about link state updates, show IP OSPF events. This is something I want to share. So as we discussed, for every LSAs, it maintains a sequence number. That's beyond this topic, but as we discussed, it maintains its sequence number right over here. For the LSA type 3, this is a different sequence number. For LSA type 1, this is a different sequence number. And coming back to this, so you can see lot of LSAs that's being exchanged. So this is actually very helpful command when you do your troubleshooting. You have to, if you want to check all your LSA types, it's being exchanged. I want to show you the states exactly here. If I take this color, so right over, if you see here, the neighbor is 20.0.0.1. So it started the exchange state, exstart state, two-way to exstart, right? This is not in a sequence, but you see the two-way state, exstart, exchange, loading, and full, right? It goes right from the bottom. So in the beginning, it will be in the down state, the neighbor 10 dot, sorry, 20.0.0.1. Let's see who's that neighbor. I have some glitches here. I cannot use my tabs. So let's see who is the neighbor. I mean, I am on R1, so I'm going to check show IP OSPF neighbors, and this is 20.0.0.1. And if you see, this is Ethernet 0/2, and this guy over here R3 is 20.0.0.1. If I jump back to R3, and if I see show IP OSPF neighbors, it is in full state, and it is telling that DR is 20.0.0.3. So that is R1 here. We gave show IP interface brief. This is 20.0.0.3. And coming back to R3, I gave show IP interface brief. It is 20.0.0.1. So what exactly happened? This 10.0.0.2 is in area 0, so we don't want to focus on that. So 20.0.0.1 is in area 1. You see the config, show run interface Ethernet 0/2. Sorry for that. I mean, I have to give show run section OSPF. That will actually give me the area type. So this is in area 1. And let's see if I shut down this particular port. I'm on R3. So let me go to interface Ethernet 0/2. If I do a shut, so we should see all the packets now. So it went to the down state. Let me do a capture right over here. I'm on R3. And if you see the port Ethernet 0/2 goes to R1. So I'm going to capture Ethernet 0/2. So who is 20.0.0.3, and it is, as I said, this is a multicast address. It does a multicast. I mean, it sends this OSPF hellos to this multicast address. Broadcasters, I mean, it does a broadcast to this multicast address. So all the routers. So in our topology, we got only 2 routers here. The logic remains the same if you have n number of devices, as many devices you have, and if all the devices are in the same area, so this is going to flood this, and all the other devices going to receive the update. So let me go to the capture. So right now, 20.0.0.3. So do show IP interface brief, exclude unassigned. So R3 is 20.0.0.1. We know this here. This is R3. So 20.0.0.3 is this guy, R1. So let me jump back to R1 now. Show IP, OSPF events. So you are going to see the same information right from the Wireshark, but the Wireshark helps you to organize everything properly. So if you see this election process happened for 20.0.0.3 and 20.0.0.1, and this guy became a DR because it got the highest IP address in the same network, 20.0.0.3. So it becomes a DR, and this became an BDR. And now let's go to this device and we'll bounce the port. We gave show IP interface brief, exclude unassigned. Let me jump back to R3. So it is admin down. So I'm going to enable this port, interface Ethernet 0/2, IP OSPF, network point to point. I just want to check one more command. Okay, let's go to this Ethernet 0/2. No shut. Let's jump back to the Wireshark. It's expected sending a Cretaceous R. So we got all our packets, database descriptor packet, link state update packet, link state acknowledgement. So let's stop this capture. We got all this OSPF packets. If you go right from the beginning, so if you compare the PPT, so if you see right over here, so it sends the database descriptor packets with all the LSAs. Yeah. And if you see here, once this exchange happens and both devices are exchanging this databases, you can see all your link state request, link state update, and link state acknowledgements, and it goes to the full state. Let's jump back again to the lab. So inside this 20.0.0.1, and this guy, right, R3. Let me little bit minimize this. So R3, 20.0.0.1, right over here, this guy, R3. So he's sending a database description packet, right? So if I open this, so what are the information it sends? So it's sending this interface MTU, this default 1500. And if you see, this is an init state. And as I said, both will be the master in the entire database. So it is telling that, yes, it is a master, and you see the init state. And if you see this, I haven't shared any kind of, it is telling that, okay, I'm ready for link state database synchronization. But do you see any kind of LSAs right over here? No. So in the same way, 20.0.0.3, the guy over here, R1. So it is also sending the database descriptor packets, and it agrees. And if you see, both are in master state, and this is in init state. Since I enabled the NSSA, you see the NSSA is supported. Not so stubby area. We will come to that, but that's out of this particular topic now. So both devices, both are sending this database descriptor packet, it agrees upon to actually share their link state advertisements, your LSAs. So this guy is 20.0.0.1 is an LSA on router 3, and 20.0.0.3 is the LSA on router 1. And if you look at this link state request, so this guy is requesting for a link state request. Yep. So the advertised router is 20.0.0.1. Who's doing this? This guy, router 3. Yeah, he is sending that. He's asking for R1 to give its LSA information. So what is an R1? If you see this 20.0.0.1 is R3 right over here. Let me take my pen. Right over here. And it is expecting the link state advertisement from R1. So if you see this link state update, let's see what is inside the link state update. So the 20.0.0.3 R1, now it sends an LS update. If you see this right over here, it is sending the 20 network 20.0.0.0 because this is configured over here. And it is advertising its subnet mask. And if you see the advertising router is 20.0.0.1. This guy is asking from this guy, and what is your network information? And it is telling that I'm configured with 20.0.0 network. And you see the metrics of 10, your subnet mask value. Yeah. And if you go to the link state update from 20.0.0.3, this guy. So it says that, okay, my link state is 20.0.0.3, this guy. So this is the IP address of the designated router. Even I know this is a designated router. So this is a transit network. So we'll discuss about what is transit network here. So basically here we are sharing all the link state updates. So in the link state updates, it's actually sharing its LSA type 1 and LSA type 2. So how do I verify all that? So in the link state acknowledgement, it is telling that you have to pay close attention to this. In the link state acknowledgement, you will actually see your LSA type 1 and your LSA type 2. So 20.0.0.3. So the advertising router is 20.0.0.1 R3. So it is sharing its LSA updates, LSA type 1 and LSA type 2. We discussed this. All the connected interfaces detail and along with the who is DR and BDR details. So network LSA, type 2 LSA, it is for DR and BDR election. LSA type 2. And also you see the LSA type 3. But this is, from all the updates from this particular area, it is a summary LSA to this area. Let's say, example, what is summary LSA? Because I don't know about 10.0.0.0 network because I am in the same area. I know about the directly connected network, and also I know about DR and BDR, and I don't want to know what is on this particular network. So what exactly the ABR translate this LSAs as a summary LSA to this guide. Let's see in the routing table, you guys will understand better. So basically in the link state acknowledgement, you see all your LSAs, LSA type 1, LSA type 2, and LSA type 3. And we'll discuss about LSA type 4, 5, and 7 in detail. But right now, this is how you should see. And when you're making a neighborship, and you have a problem, and if you have a vendor or you have a device that can be something you cannot access the device through telnet or something, when you try to get the packet capture of this, you have to go through all this information. So if there is a if your OSPF neighborship is properly happening and if it is successfully established, you should see the packet right from LSA DB packets, the database descriptor packet, and you should see the link state request, you should see the link state update, and you should see the link state acknowledgement. Now let's say if I go to router 3 and if I do show IP OSPF neighbors, you can see the state is full state. And if you see show IP OSPF events, you can see the same thing here, type 1 LSA, link state ID, but this is not organized, right? So this helps you to figure out, is it my LSAs are actually exchanged and my DR and BDR election is happening here? We take a different color. So my DR BDR election is happening, and from init state it went to two-way state, exstart, exchange, and it becomes a full state, right? As I said, this is, you know, it's a kind of mess. You cannot follow everything here, but right over in the Wireshark, you can see how sequentially it is showing the data. Right from your descriptor packet until the acknowledgement packet. So it is in full state now. So that is about OSPF packets. And now let's quickly jump into the OSPF network types. So now a quick a recap what we discussed so far. So we saw when I manually shut down the interface or if there is any changes to the network, yeah. So it's going to advertise everything through my, if I do any changes in R2, as I said, it will do a link state request for this guy and R will send the link state update with the updated information. And for this link state update, the R2 will send a link state acknowledgement to R1. That's how you can compare your logs with Wireshark, as well as in the show IP OSPF events will show all your LSAs types has been exchanged. Now I want to show you one more thing. So how it is building the database. So I am on R3 here. If I give show IP OSPF database, let me take the pen, different color. Okay, so if you see here, let's not talk about type 7 LSA right now. Let's go here. Yep. So I am on R3, this guy. So this is an area 0. And if you see this guy, right, this guy is in 10.0.0.2 over here, 10.0.0.2. And it is telling that this guy router 2, right, this is an advertised router 2 is sending this information about this. And I see only this on R3. If I jump back to R1, this LSA, let me minimize this. This LSA over here, it's never been flooded to this area. This stays within the same area. And only this ABR right over here, only in the ABR would see that. Yeah, this guy. will know about this LSA. So I'll show you that what is the output I see in R1 here. R1, we are going to check the OSPF database. Show IP OSPF database. So it came as a summary LSA, but if you see the output on R3, it is showing the exact address 10.0.0.1. And if I go to R1, I see only the 10 network, but I don't know which device is that 10.0.0.1. So who is advertising this? This ABR, this guy, it's sending as a summary LSI here. He is sending as a summary LSA. Guys, I mean, this OSPF is it's with a lot of information and details, and I would suggest definitely you guys have to do a lab. Only then you guys will understand this. So I will definitely suggest everybody should practice this lab. Only then you will see how this LSA types are exchanged and what is the other OSPF packets we discussed about link state update, descriptor packet, and everything. You will remember forever when you do a lab. So I would again, I will hardly insist everybody to do a lab to understand this whole thing. Yeah, coming back to this. So I cannot see who is advertising this, but I know about this network because 20.0.0.1 is told me, this guy R3 told me that if you want to reach to 10.0.0.2, you have to come to me. We give show IP route OSPF. You see, if I want to reach 10 network, I want to go to 20.0.0.1, but I don't know the LSA type 1. I don't know the connected network. Here it is 10.0.0.1. But if we go right over R3, because it got the router LSA, and I know who is 10.0.0.1, but this guy over here, R1, doesn't know who is 10.0.0.1. You can verify that using show IP OSPF database, and I don't see who is that. But the network LSA, I know about this guy because this is a non-broadcast multi-access network. I know about 20.0.0.3. This guy is a DR and I am the BDR, and I know the directly connected link even in the LSA type 1. We discussed about that. So all the connected networks are LSA type 1. You will see the whole topology. It remains the same for this and between the devices in the same area. If we go to R3, you will see the same type 1 LSA, router LSA 10.0. Sorry, I mean 10.0.0.1 belongs to this. I know because this router R3 is an ABR, so you see this, but 20.0.0.1, right? This guy, 20.0.0.1. And in the router LSA, if you see, it's an updated message, so it knows about 20.0.0.3. This is again a router LSA. It's an area 1. But this is a router LSA on area 0 because this guy is in area 0. This guy is in area 0 and area 1. So I know about the router LSA type 1 from both areas. So I know about in area 0, I know the connected network is 10.0.0.1 and 20.0.0.1 is my connected device, and 20.0.0.3, and it's in area 1 type 1 LSA 1. This is also LSA type 1. So but this is an area 1. I know about 20.0.0.1. I am on area 1, and 20.0.0.3, this is also in area 1, and but this is in area 0. And as I said, if you go back and check your R2, And if I give show IP OSPF database, I don't know about 20.0.0.3. If you see the type 1 LSA right over here, I don't know about 20.0.0.3, but this guy 20.0.0.1, he is in the area 0, so I know about this guy. But I don't know about 20.0.0.3 in LSA type 1. But if I want to reach 20 network, the network LSA for this guy, right? For this guy, if I want to go to this area, so the advertised router is 20.0.0.1 and this guy is an ABR. And in the CLI, how do I find who is my ABR? If you give show IP OSPF border routers, so ABR for my, I mean, for my area, who is the ABR is 20.0.0.1. This guy here, 20.0.0.1 is my ABR and my A is BR. So how I reach 20.0.0.1, I will go through 10.0.0.2. It's my next hop. Through that, I can reach 20.0.0.1. So this is the intra area route. So that is the difference, right? Let me take this. So all this are inter area. This is inter area. All this LSAs within area 0, but between the areas or intra area routes, because this is from a different area. 20.0.0.1 is in a different area, area 1. But all I know about is area 0 here. So ABR is the predominant translator here. I would say the only translator here to help the R2 to reach R1 in a different area. Show IP. So show IP OSPF border router will show you who is an ABR and who is your ASBR. So when I do the same command on R1, if I jump back to R1 right over here, this guy, we jump back to R1, show IP OSPF border routers. So this guy, it's again for him because the ABR is, he has to be in more than one area. So one area is a backbone area, area 0, and other than that, he has to be in a different area because he's interconnecting a different areas here. So even for me, R1, my ABR and ASBR is this guy. And if you give show IP OSPF database router 20.0.0.1, this is again will give me who is my area border router. This guy 20.0.0.1. Either with two commands you can check who is your ABR. But for your quick finding, you can do show IP OSPF area border routers. Sorry, show IP OSPF border routers. So I gave all these commands in the PowerPoint. Some of the useful commands for your troubleshooting: show IP OSPF database, show IP OSPF border routers will give you an ABR and your ASBR. So that's it about so far. We covered OSPF packets. We talked about LSA type 1, type 2, and type 3. And we saw that in the packet capture. And followed by that, let's quickly move forward with other area types. So LSA type 4. So LSA type 4, who is LSA type 4? So let me quickly give a background. Okay, this guy over here, R3, let me take a pen. Okay, this is a device in the area 2. So this guy, he has to know about this ASBR, right? I want to know who is my ASBR. Other than that, I mean, how I get my redistributed routes. Because here, if you see, I am redistributing the routes, the BGP routes into OSPF. And without knowing this ASBR, I cannot get this route information from BGP over here. So ASBR summary LSA packets are the LSAs that advertise the presence of the autonomous system border router. So if somebody is asking a question, so what is LSA type 4? So LSA type 4 will give me who is my ASBR, who is my autonomous system border router. The autonomous system border router is the router where your redistribution happens. When you inject your other routing protocols into OSPF, so that is your ASBR. So exactly here, we are advertising this to SBR, and we'll see that in the lab. I have the same kind of topology. I am advertising the EAGRP to the ASBR, and we'll see how we can find it. So in our topology, let's quickly jump back now. Okay, so if I go to this guy R1 again, show IP OSPF database, and I want to show you one thing. In addition to that, if you see this whole the whole thing, the whole output of show IP OSPF database is your LSDB, link state database. And every single update here is your LSA. Your LSA, your LSA, your LSA, your LSA. So let me differentiate with a different color here. So whole thing is LSDB, and every individual values over here is your LSAs. This is very important. So now we are talking about the autonomous system border router, right? Okay. So to know my autonomous system border router, I should understand, okay, so LSA type 4, we are talking about redistribution. Okay, so now the whole logic is, I'll come back to this. I want to give you a little more background and a little more information about type 4 LSAs. So here the whole objective is for this R4 router, he has to reach the BGP routes. I mean, it's injected through R1, I am receiving on R4. So, but why should I receive all the updates? So all I need to know is if I know who is my ASBR, I can reach my BGP. That's the whole logic here. Let me erase this, go to my pen. So this thing, right? So if I want to know about the ASBR, so I should receive the LSA type 4, summary LSA, which advertises the ASBR route received from area 1 and inject to area 0. While LSA type 4 packets are used by ABRs to advertise the ASBR routers through their area, it will not be used by ASBR itself within its local area. ASBR uses LSA type 1 to inform its neighbor R2 within its network. So, example, if these two guys, right, for him, he is going to advertise this LSA, this ASBR is going to introduce himself through LSA type 1 within the same area, within its network, right? So, but if it is in a different area, the ABR has to translate this LSA type 4 to this guy. LSA type 4 to the R4. I mean, let me redraw this. So my ABR is the complete responsibility to translate my ASBR. He has to advertise this to this guy, right? Right over here. This is again in ABR. Both are in same area. So this guy will tell me that this is your ASBR. Who is the ASBR? This guy R1, right? R1 is your ASBR. Let's quickly go and do that. So I see summary LSA, I see network LSA, I see router LSA type 1, network LSA is type 2, summary LSA is type 3, and this is type 7. Let's ignore at this point. So if I do, I am on R1 right over here. This is my ASBR R2. I should know about R2, but right now I don't know because the configuration, I'll tell you what to do to see the ASBR. So instead of that, so I'm going to router OSPF1. This is very simple topology. So let me remove this area as a not so stubby area. I have to start with no command. Area 1 not so stubby area. So one more thing, if you have your area types, it should be same on both ends. So now I am running, now I removed this not so stubby area here. I mean, you don't worry about that not so stubby area. We'll discuss about that. So now this area doesn't have any special area types. It's just a common area. So I removed this in R1. I have to quickly jump into R3 right over here. Enable show run section OSPF. If you see this went to downstate, we give show run section OSPF. And this is an area 1, not so stubby area. I have to make it as a normal area, no special area type. Router OSPF 1. So now it should, yeah. So it came to the full state now because I removed the area types. Show IP OSPF neighbor, set in full state. It's 20.0.0.3. This guy R1 20.0.0.3. You can see here 3.3.3. Jump back. Open the terminal. Fine. So this guy is again elected as a DR because it got the highest IP address R1. So if I go to R1 and if I see show IP OSPF database, so now if you see ASP link state is your LSA type 3, sorry, LSA type 4. LSA type 4. So if you give show IP, OSPF, let me go back to the command. Show IP OSPF border routers. So so it is telling that now my now I'll show you where how exactly I redistributed. So the whole point is for R1, it is telling that my ASBR is this guy 10.0.0.1. If I give show IP OSPF database, it says that my autonomous system border router is 10.0.0.1 and it is coming through my ABR 20.0.0.1 right over here, R3 20.0.0.1 configured on this particular interface. And if I go to the router LSA, I don't know about 10 network, but this is being advertised and this guy is an ASBR. I come to know about this guy through LSA type 4. So who is helping me to find this guy? So the advertised router is 20.0.0.1, this guy. So the ABR translates your type 4 LSA to the other area. So from area 0 to this area 1, your ABR is actually translated this type 4 LSA. So far good. So let's go to LSA type 5. So your LSA type 5 is, let me erase this. So your LSA type 5, so your LSA type 5 is your redistributed routes. Example, here I advertise the BGP and in R4, it comes as a LSA type 5. So how do I see that? If you see this this 30.0.0.0 network, right? So again, the advertised router here, it is telling that 10.0.0.1. So the redistribution, who is doing this redistribution? This guy over here is redistributing my EAGRP to OSPF, EAGRP to E2, EAGRP to OSPF. It's redistributing, and I get this as a type 5 LSA. And here I can see my type 4 LSA. Here I can see my type 2 LSA, 2, sorry, this is summary LSA 3, 4, 5. This is redistributed route. Redistributed from EIGRP to OSPF. So if I go back to R2, let me show you exactly what we did. Show running section OSPF. So here I am redistributing. So if you see show run section EIGRP. So through EIGRP, I mean, let me quickly do this. Copy this. Let me create. Let me make it 15. the EIGRP. So the network hanging over here is 30 network. And if I jump back again to the lab, so if I give show IP interface brief, exclude unassigned. So if you see this Ethernet 0/0, right? It's an R2 Ethernet 0/0. Let me take my pen. Here, it's configured over here. And this 30.0.0.2 is configured right over here in R2 Ethernet 0/1 that is connected to my 3725 switch, the multi-layer switch. And on 3725 switch, it's marked as -2 is this guy over here. If I jump back to this, show run section EAGRP. So I'm not running any OSPF route. So here I'm advertising the 30 network. If I give show IP interface brief, exclude unassigned, to see 30.0.0.2 right over here, 30.0.0.2. So this guy here, 30.0.0.0.2. Come on. And this guy over here is 30.0.0.1. Here 1, this is 2. So you guys want to understand better, so I'm giving this explanation again and again. Coming back to the outputs. So here I'm redistribution. So my redistribution happens in R2 over here, ASBR. So show run, yeah, here you can see that output, we got it here. Okay, redistribute EAGRP, the metric is a random value, and I'm advertising all the subnets over here. So if I go to show run section OSPF, so here you can see I am redistributing the EAGRP routes, the 30 networks here right over here to the OSPF network. So all this about this 30 network, it goes as a type 5 LSA to R1. So I know about 30 network, and my ASBR is this guy because I know about my ASBR. The link state ID is 10.0.0.1. And who sent this? About my how I know about my ASBR, because my area bound router 20.0.0.1 has given the detail about 10.0.0.1. You can jump on to R1, and if you can see the link state ID is 10.0.0.1, it belongs to R2 over here. So now we learned about how type 1 LSA, what is type 1 LSA, a quick recap, all the connected routes within the same area, type 2 LSA coming back to the area 1, and it happens only in the non-broadcast multi-access network, and it will send all the information about my DR and BDR, and and my DR is responsible for the whole LSA, flooding within that same area. And apart from DR and BDR and the other routers within the same non-broadcast multi-access network will be DR other. And it holds, let's say, type 1, type 2, and type 3. The type 3 is actually helpful to reach the other area from area 1 to area 0. If I want to go, I want the summary LSAs, it summarizes the routes and send it to the other area. Through the summarized routes, I can reach the other area. And if it is redistributed, it is a type 5 LSA. So I received the type 5 LSA. So my ABR is actually translating that, and we saw the commands. How do you check your area border router? How do you check your autonomous system border router, area border routers, and how to check your link state database and how to see your link state advertisements. So example here, if you see, if a question somebody is asking, so how many LSAs I got? So I got about 30.0.0.1 here from the R2 perspective and 10.0.0.1. So I got two LSAs here. But this LSA 30.0.0.1, if you go to R2, if I go to jump back to R2, if I give show IP OSPF database, so if you see this guy, my router LSA here, I am on R2. My router LSA is 10.0.0.1 and 20.0.0.1. Can you please, you guys have to, if anybody know the answer, why I don't see 30.0.0.1 30 network as my router LSA? You guys can ping me in the chat if you know the answer. I will answer this. I don't see this 30 network as my router LSA here, even though it is directly connected. Why? So tomorrow we'll discuss about the area types, because we discussed about the normal area, we discussed about multi-area, we got other four very important areas. We'll see the configuration and the database when we do the changes, how it changes. So it is about your stub, your stub area, and stub not so stubby area, and I mean, again, I mean, I'm a bit. It's actually very hard to remember the areas. So again, I'll tell you. So we are going to discuss about tomorrow is a stub and stub no summary, and then not so stubby and totally stubby area. So we are going to discuss about other four areas, because it's getting redistributed because 30 network is not in the same area, not point to point network. Cool. So yep, I'll answer about this in the Q&A session. So guys, so tomorrow we are going to discuss about the other four important areas. So let me stop sharing now. Yep, if you guys have any questions, you can ask me. We'll answer that Q&A questions shortly.
So Praveen, question is how this LSA4 getting generated? A little bit I have doubt because LSA5 is external LSA which is getting redistributed. But what about LSA4, ASBR LSA?
Not okay, ASBR LSA, because it is an ASBR, right? I mean, if I want to reach the EAGRP routes, because it is redistributed, so it has to, I should know who's my ASBR, right? So if only if I know who's my ASBR, I can reach the EAGRP network.
So whenever there is LSA external route, then only ASBR come in picture, right?
Yeah, absolutely. Yes. Because when we doing a redistribution happens in the ASBR. Yeah.
Okay. And one more doubt is like, what is the difference between the so IP route, OSPF, and so IP route?
So IP routes is it will give you the routes about all the routing protocols, irrespective of if you run your static route, you run your EAGRP, it's going to display all your routes. But show IP route OSPF will give you only the routes which OSPF learned. I mean, the only through the LSA updates and everything, it builds its own routing table, right?
Okay, okay. Means, but decision only make on the basis of what in the routing table, so IP route.
The best routes will be in the routing table. OSPF routes is something, whatever the routes it learned, you will see all the route information in your OSPF routing table.
But decision only like the decision will be happen on the basis of the so IP
Route,
routing table.
absolutely, absolutely. Yeah. We
Okay.
have one more lab for routing logics, how exactly the routes select, how this precedence happens, route precedence happens, and how exactly the, based on different routing table and routing table entries, how this route is going to decide and, takes a precedence over the different routes. The route
Okay.
decision, I would say, how the router decides to reach a destination based on multiple routes to the same destination. We have a lab for it. Yeah.
Hello, Praveen. Hi.
Hi, Deepa. Yeah.
LSA 4, what my understanding, LSA 4 is shows the is where router details, right? And LSA 5 shows the redistributed route details.
Absolutely. Yes.
And one thing, actually, lots when I see in Wireshark, okay.
Mhm, mhm,
So lots of parameters are there. Okay,
mhm,
means under every header.
mhm, mhm.
So do you have any process? How can I remember all of this? Means lots
Yeah,
of
no, no,
parameter.
no. Yeah, yeah, I totally get it. So you have to focus only on the key packets what we discussed. Example, you have to know about your link state update. You should know about your link state request, and you should know about your link state acknowledgement, your database descriptor packet. That's it really. For your OSPF packets, that's fine for you. That's something when you're troubleshooting something, that helps you to figure out, right? If your neighborship was, you get stuck with your xstart states, then if you're not seeing your LSA, link state request or link state update, so it means that your OSPF configuration may be a misconfiguration, or maybe the neighbor device is not yet configured with OSPF. So that's how you can correspond your values with Wireshark and the actual outputs. You have to play around with both values.
Okay, and it is possible. Means I have created one lab in EVNG. Okay.
Hmm, hmm,
Now I just copy this lab in another lab and will
hmm,
change some. Okay, something just I will change, not so much. So is it
hmm.
possible to copy the lab to another new lab? It is possible.
That is something I have to check, but in GNS
Okay,
we
okay.
save labs, but
Ha
I
ha
never
ha.
tried in EVNG actually. I mean, I have to check,
Okay, okay.
is there any possibility to save the EVNG labs? I'm not sure about that. I'll research on it and I'll come back to you.
Okay, okay, okay. Okay. Thank you, Praveen.
Yeah, yeah, no problem.
So Praveen, one more question. To make the NBMA network,
Mm.
you have used the command under the interfaces. So generally in production network, those commands are not needed because not needed, right? Because they are already in full mesh and like that only, right?
No, no, it's purely depend on your design. You're
Okay.
designing your network. If you want to build your multi-access network, you have to use the same commands to build your multi-access network. And if it is just a point to point, yeah, the command is for IPOSPF network type point to point.
Okay.
So it
Suppose
depends on your design.
okay. So suppose if we have 3 to 4 router in area one and they are in full mesh, so in again we needed those commands
Yeah,
as
absolutely. If
a
you see,
okay.
you have to find the difference between the point-to-point and multi-access, right? If you want to build it as the same broadcast domain, and you have a switch in the middle, a core switch, and if you want to build four routers in the same area with broadcast network, yeah, you have to use that command. If you want to build a connection like a point-to-point connection and you don't need a DR-BDR topology, then you have to use a point-to-point command. So it depends on your design, your requirement.
Okay. Uh,
But
uh,
we haven't we haven't built the broadcast network actually. We are only using point-to-point.
mm,
And even
because
we have a very flat network. We are not using multi-area OSPF. We are using just one flat area 0.
okay, because I'm using the HPN boxes, uh, uh, Comware HPN, and
Sorry,
I
what
have
is that? What is that? Can you be a little louder?
actually we are using HP boxes,
Okay.
HPE boxes.
Okay.
It's not the Cisco boxes in my project.
But
So
I think the commands maybe I think I'm not sure, but
I
the
have
commands are managed.
formed I have formed the OSPF between my switch and the firewall.
Hmm.
But and it is when I do this display OSPF here, there is a display command is running. So I run the command display OSPF here. Under that, it is showing as a DR-BDR, but I not use there as a NBMA network.
Check your interface type. Check your interface type. Is it your network type is broadcast?
Okay.
See, if you see, but I am very sure about this. See, irrespective,
Mhm,
regardless of
mhm.
any vendor device, but if it is you see DRBDR, then definitely you are using a broadcast command. You're doing it as a broadcast network for sure.
So what I have to check interface? I didn't get you that point.
You can give show IP OSPF neighbor, and if it is showing as a DRBDR, then definitely you are that particular interface. You have to go and check is it you enabled the broadcast network type in that interface.
Mhm. Actually, myself only created, but I never used any command.
No. You have to check your running config. I'm very sure BDR and DRBDR election will never happen in the point to point. I'm very sure about that.
Okay. But because I have did the full configuration of that box and I formed the means
You saw that, right? I mean, the output which I have shown
yeah.
the in the
That's why
area 0 there is no BDR, DR, BDR because it's a point to point.
I agree with your point. Means I not worked on the Cisco right of now, so that the reason this question came in the point.
No.
But
This is not respect. I mean, see, the logic remains the same. See, we are using the same open standard OSPF. So
Mhm.
if it is a DR and BDR, it should be only the broadcast network, not point to point. As simple as that.
Yeah,
Yeah.
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 Because
You have
what I
to. I would suggest you should go through the complete config. Definitely, you're missing something. That should be a in a broadcast network. Yeah.
okay, okay. If I have doubt, shall I ping you on your WhatsApp? It is if you don't mind.
Yeah. That's fine.
Okay, okay. Yeah. Okay. Thank you.
Yeah. No problem. No problem, Emma. Yeah.
Hello, Praveen. No, NVMe network. Okay.
Mm-hmm.
Is it point to point, no? Because NVMe, non-broadcast multicast access,
Multi-access.
multi-access.
That is a
So is it
broadcast.
that is a broadcast?
Yeah,
And
broadcast network. The naming convention is a bit confusing, but
okay,
DR and
okay, that
BDR it
is
is.
this is okay, okay,
So you can always remember like this. NBMA is a broadcast
okay,
because it is in the same broadcast domain. You are using multiple routers in the same area, and it's a broadcast, and it is a point to point is one to one, right? The one link goes to the other link of the router, and it is a point to point. But here you are using one switch in the middle and you are connecting multiple routers. All are in the same area and the network type is broadcast.
okay, okay.
Yeah, when you play around with the lab, you will definitely understand. I'm very sure.
Yeah, but I have to see again your video. Okay. So, but video uploading is very late. So this is the issue. Means I
Mhm.
have to wait for next week